Today we are going to study double integration. In this topic we are going to see what is the definition, properties, and examples, which are very important for the examination point of view. So immediately we'll go with the definition, properties, and examples. Students, please watch the video till the end. We see that so many examples which are important in the examination. Today's topic will be discussing double integration, students. So once again, welcome to the YouTube channel Engineering Mathematics Made Easy for All. We see the definition and properties of double integral. So definition says that the definite integral can be extended to functions of more than one variable. Consider, for example, a functions of two variables that is equal to f of x comma y. The double integral of function f of x comma y is denoted by integral of f of x comma y d of a, or we just take this as a function of two variables where r is the region of integration in the xy plane. So this is just a simple definition. Then we come across the another view how the integration looks. So if the definite integral is integration from a to b f of x dx of a function of one variable f of x greater than or equal to 0 is the area under the curve f of x from x is equal to a to x is equal to b, then the double integral is equal to the volume under the surface z is equal to f of x comma y and the above xy plane in the region of integration r. So here we can see very simple how the integration looks. Yes, geometrically this is how the integration looks. Symbolically we write it in mathematics. So this symbol is nothing but it represents this z is equal to x comma function of x comma y. So we go to the next one, properties. So properties of double integral, students. So double integral satisfies the following properties. So first property is integration of integration f of x comma y plus g of x comma y d of a is equal to integration of integration f of x comma y d of a plus integration of integration g of x comma y d of a. So this is with respect to a we have taken. So same way similar next property we have integration of integration f of x comma y minus g of x comma y into d of a, which is equal to integration of integration in the region r f of x comma y dA minus integration of integration r g of x comma y dA in the region r. So third property we have here, students. So this is addition property and this is subtraction property. We also say this as linear property. Is it clear, students? So next we'll go to the scalar property. It is also known as scalar property, where scalar k is constant is multiplied in this. So integration of integration in the region r k into f of x comma y d of a is equal to k integration of integration r f of x comma y d of a, where k is constant. Okay, so this is third property. Fourth property, I can say this is if f of x comma y is less than equal to g of x comma y on r, then in the region r, so then you can see integration of integration r f of x comma y d of a is less than equal to integration of integration r g of x comma y d of a. So this satisfies, students, if the function is less than g of f is a function which is less than equal to g, then integration will be also less than equal to, students. This is very important. Next property is fifth one, if the function x comma y is greater than equal to 0 on r and s is subset of r, then you can see integration of integration s f of x comma y d of a is less than equal to integration of integration r f of x comma y d of a. The meaning of this property is that there is some s which is already there in r. So this s is a subset of r, means s belongs to r, s is in the part of region. So if you take this as some region r, somewhere here s is there. So this is r, so r is bigger one, s is small. So integration of this s will be always less than equal to this r region. So this is the property fifth one. Okay, students, so remember the definition. Please go through the definition once again, rewind the video and you can watch the definition. Next you go through the properties, very important. Then we will go to the next one, the example. So quickly take down the example, students. So first example we are going to take example 1. Evaluate, very simple question they will ask in the examination, students. Evaluate integral 0 to 1 by 2 integration 0 to 1 x divided by square root of 1 minus x square y square dx dy. Yes, students, immediately you can see very simple equation. So please, every time whenever they give the equation in this form, please rewrite this equation. So we write 0 to 1 by 2 integration 0 to 1 x divided by square root of 1 minus xy the whole square dy dx. So looking at this example, friends, we can easily find out that integration of x divided by square root of 1 minus, so we can take this as x as the constant a, so this will become ax dx. So we can easily find this ones. This is nothing but the sine inverse x. So please remember this formula, students, which is very useful for integration ax divided by x. So this formula we are going to use. So just integration 1 divided by square root of 1 minus ax, integration will give you sine inverse ax divided by x. Please remember this formula, students. Now when we are taking here, x is going to become constant, so I will take it out, x outside. So integration 0 to 1 by 2 x, I will take it outside. I'm going to integrate only integration 0 to 1 divided by square root of 1 minus xy the whole square dy dx. Only this part I'm going to integrate here, students. So therefore this is going to become integration 1 by 2 x into sine inverse xy divided by x in the limit 0 to 1 dx. So here we consider x as a constant, so x I'm going to take here a, so please consider this is square. So integration 1 divided by 1 minus ax the whole square dx is equal to sine inverse ax divided by x. Is it clear, friends? So this formula I'm going to use here. Please note down this formula, friends. Then now I'm going to substitute wherever y is there, lower limit 0 and upper limit 1. Okay, so therefore this will give you, this is equal to integration 0 to 1 by 2. Now easily you can find your, students, this will give you sine inverse x dx. So when you simplify, you will get here. So here you can see this x and x will get cancelled. Please see here. Then 1 and 0. Y is going to become 1. 0 is 0. So you can say that this is integration 1 by 2 sine inverse y is 1. So x minus sine inverse 0. So 0 will give you sine inverse 0 is 0. So sine inverse x you will get. So I have written integration of 0 to 1 by 2 sine inverse dx. So simplify this, friends. Now x is the variable, so this is going to become now first sine inverse x integration, friends. Please remember this, x sine inverse x plus square root of 1 minus x square in the interval 1 by 2. So integration of sine we have done, but please remember the integration of formula sine inverse x will give you x sine x plus square root of 1 minus x square. So please remember the formula, students, of sine, very important. You can see such type of problems will come in the exam. So this is equal to, now you substitute 1 by 2. So here we can see this is going to become 1 by 2 sine inverse 1 by 2 will give you pi by 6 plus 1 by 2 square root of 1 minus 1 by 2 square and minus this is 0. So 0 is going to give you 0. This is equal to pi by 2 0 plus square root of 1 minus 0. Just substitute x is equal to 0 and x is equal to 1 by 2, students. So here you can see pi by 12 plus, so 1 upon 2, the whole square is 1 upon 4. If you take the LCM, 4 minus 1 is going to become 3. So this is going to become 3 square root 4. Square root 3 divided by 4 minus, here 0 is 1. So square root 1 is 1. So therefore we say this is pi by 12 plus root 3 divided by square root 4, students. Please remember this is 2. Just take 2 minus 1. This is the answer, students. So please divide. Once again, look out the formula, students. Very, very simple. And please practice such type of example, students. Okay. So next, immediately we'll go to the example number 2. Yes, students. Just they will give in the examination. Evaluate integral 0 to pi, integral 0 to a cos theta or sin theta into dr d theta. Okay, students. Please calculate this example now. I will take I is equal to, first rearrange, first you take r and then you take theta. So here you can see this is with respect to r is equal to 0, r is equal to a cos theta, and this is theta is equal to 0, theta is equal to pi. So no need of rearranging, students. So you can see sin theta is constant. I will take it outside. So sin theta, only we are going to integrate 0 to r is equal to a cos theta or dr d theta. So in exam they may also give in terms of r and theta. Let's see here, it is 0 to a cos theta, means you have to integrate with respect to r. So therefore I have taken this r here, students. So this is going to give you integration 0 to pi sin theta, no change. I am going to take only integration of r. Integration of r with respect to r, like integration of x raised to n with respect to n is x raised to n plus 1 divided by n plus 1, or we can just see it is x raised to 1 dx will give you x square upon 2. Same way r will give you with respect to r is r square upon 2. So therefore this is give you r square upon 2. Lower limit and upper limit, please write down. So this is what the simplification you will get. So now here 2 is constant is there, 1 by 2. So I will just take out 1 by 2 outside. I don't want to integrate this. Next, integration 0 to pi sin theta as it is. Only I am going to put r square, students, r square as a cos theta. Okay, so then first I will put upper limit, lower limit is 0, so I will not write. I will only write the value a square cos square theta d theta. Yes, students, you can see r square I am going to take this as minus 0. So I am not going to write that 0. Please understand the integration formula. Very simple. Next, you can see only theta I have to integrate. Therefore, I'll just take this a square outside. So therefore, the next step is going to become this is equal to. So here we can see, students, this is a square divided by 2 will give you. Now I want to simplify this. We don't have anything for sin theta d theta. Sin theta we cannot simplify. Therefore, I will just substitution method. I will just differentiate cos theta. So everybody knows differentiation of cos theta. Yes, students. It is minus sin theta into d theta, or I say that sin theta d theta will be equal to minus differentiation of cos theta. So this substitution I will do here, students, immediately. So therefore you can see this is integration 0 to pi cos square theta, just substitute minus d cos theta. So minus I will take it outside. So this will give you minus a square upon 2 integral 0 to pi cos square theta into d cos theta. Yes, friends, easily you can see here that this integration is looking like this. So just take x is equal to cos square theta, then integration of x will give you integration of cos square theta into d theta, or we just simply say that if x is equal to cos square theta, if you substitute, the integration will look like this, cos theta. Is it clear? So integration of x dx, which is equal to integration of cos square theta into d cos theta, if you integrate this, it will be x square by 2. Same way, this integration will give you cos cube theta by 3. So this is how we integrate this ones. The same way I'll substitute here. This is going to become minus a square upon 2 integration 0 to pi cos cube integration. I will just simplify put the integration front. So this is cos square theta d cos theta, which will give you minus a square upon 2 cos cube theta divided by 3 in the integral 0 to pi. So I will take out 3 outside. So this will be minus a square upon 6. 2 into 3 is going to become 6. And cos cube pi, or we can see if we substitute cos cube pi is 0. Cos cube pi minus cos 0. Cos cube 0. So this is 0. You can see you get 0. And cos 0, please see as friends, it will be 1. So it is minus cos 0 is there. So you'll get here minus 1, minus into minus plus. You will get here students. So here we can see this is minus 1 you will get. So minus a square upon 6 minus 1, or we just say this as a square upon 6 students. Okay, immediately we'll go to the next example students. Very important. You can easily simplify this integration very easily. So just we'll take example 3. Evaluate. Yes students, evaluate integral 0 to 1 dx dy divided by 1 plus x square 1 plus y square. Yes students, easily you can calculate this. I just take this as let I is equal to, first I will take y value and then I will take x value. So therefore this is integration 0 to 1 upon 1 plus x square. I will take it outside. So this is integration 0 to 1 upon 1 plus y square dy dx. So I have just taken y inside this value students. Okay, so therefore this is going to become integration 0 to 1 divided by 1 plus x square into, yes, do you remember here friends, integration of 1 divided by 1 plus x square is nothing but tan inverse x. So I'll just take this as here, instead of x we have y, therefore this is going to become tan inverse y in the limit 0 to 1. Okay students, so tell me what is the integration here. This is integration 0 to 1 divided by 1 plus x square. This is going to become tan inverse 1 minus tan inverse 0. So tan inverse 0 is 0, so consider this as 0. Tan inverse 1, please remember tan inverse 1 is always pi by 4. So this is going to become integration 0 to 1 divided by 1 plus x square into pi by 4 dx. So pi by 4 is constant. I will take it outside students. So therefore this will give you, this is equal to pi by 4 integration 0 to 1 divided by 1 plus x square dx. So therefore this is equal to pi by 4. Now again 1 divided by 1 plus x square is tan inverse x in the interval 0 to 1. So this is pi by 4. So please substitute the values here students. You will get this as tan inverse 1 minus tan inverse 0. Is it clear students? Okay, so now you can see that you can directly put the value tan inverse 0. This is will give you 0 only. Tan inverse 1 is pi by 4. So this is pi by 4 into, we get this is pi by 4, which will give you tan square 16. Is it clear students? So this will give you pi square 16. This is the answer students. Immediately go to the next example students. Very important. Example number 4. They will give you the very simple question. Evaluate integral. Please consider this integral 0 to 1 integration 0 to x square e raised to y divided by x dx. Okay students, so we'll simplify this problem. Please consider let I is equal to integral 0 to 1. So you can see here dx dy is there. First we'll interchange this integration 0 to x square e raised to y divided by x. I will just take first dy and then I will take dx. So again always please rearrange the evaluate integral 0 to 1 integration 0 to x square e raised to y divided by x dy dx is there. Okay, u into v. This is, I will keep this as u and I will take this as v. So here you can see I will keep u as it is, that is x, I will keep it as it is. Integration of e raised to x is e raised to x only. So I will take e raised to x as it is friends. Okay, this is my integration. Is it clear? So now minus integration of e raised to x. Again integration of e raised to x is e raised to x into differentiation of x students. It will be 1. So this is 1 I am going to substitute here. Then next this completes minus. Then I will go to the next one. Integration of x is here students. It is x square divided by 2 in the interval 0 to 1. So both the intervals are 0 to 1, so I have taken it in this way. So this is equal to front. So first I am going to simplify. So this is x e raised to x minus integration of e raised to x is e raised to x minus x square upon 2 in the interval 0 to 1. So first I will put 1, then I will put 0. So this is 1 e raised to 1 minus e raised to 1 minus 1 square upon 2 is equal to. So this is, I have put upper limit x is equal to, next I will put 0. So this is 0 into e raised to 0 minus e raised to 0 minus 0 divided by 2. So when you simplify this ones, you will get the value. This is e, 1 into is e minus 1 divided by 2. Okay, then next this is minus 0 into e raised to 0 is 0 minus e raised to 0 is 1 minus 0. So further if you simplify, this will give you, this is minus 1 upon 2 plus e minus e will get cancelled. Please students remember, minus 1 upon 2. Here we have minus into minus will give you plus 1. Therefore this will be equal to 1 upon 2. So this is the answer. Very simple, they have given. Evaluate integral 0 to a root 3 integral 0 root x square plus a square x dy dx divided by y square plus x square plus a square. So we will simplify this ones. So they are all double integral, please consider. So we'll take let I is equal to integral 0 to, first y is given here already, so e root 3. So first I will take y only. Let us take y only, students. Integrate. Here already they have given, so no need of changing this. Very, very important. When we are integrating, students, please see that x is a constant, so I'll take out x here outside, into integral 0 to square root of x square plus a square 1 divided by, so just a little bit modification I will do here, students. I will consider this as it is looking like 1 divided by x square plus a square. So please remember this ones. This is 1 upon a tan inverse x by a. So I have to fix the value. This is integration is looking in this way. So let me fix the value. Y square I will keep it as it is. Then x square plus a square. This must be square. So I want to make x square plus a square the whole square, so that it should look a square. So to make this a square, I'll just take square root and square. So that square root and square will get cancelled. I will get back again x square plus a square. So no, it is no harm to take square root of the square. So it is like taking 2 square root and square will give you 2 only. So same way I have taken here. So I'm going to take this square root of square dy dx. So still a little bit modification is required in this example, students. So now here you can see in this example, I'm going to take a is equal to square root of x square plus a square. In this example, you can look here from y square and x is going to become y. So then this will give you integration 0 to a root 3 x as it is into, yes students, now you can see 1 upon a. A is our square root of x square plus y square. So I have to put a in this, that's it. So this will give you, students, 1 divided by square root of x square plus a square and inverse, yes, here x I have taken y, so this will be y divided by square root of x square plus a square. That's it, students. Very, very simple, don't get confused. Then upper limit and lower limit is 0 to square root of x square plus a square into dx. So this is equal to, yes students, now when we simplify this, wherever y is there, I'm going to put first y and this is upper limit and lower limit. So this is going to become 0 to a root 3 x as it is, no change in x, keep x as it is, students. Then 1 upon square root of x square plus a square, no change as it is. Tan inverse, only this part is going to change. So first I will put y is equal to square root of x square plus y square, x square plus a square divided by square root of x square plus a square minus, this is 0 is there, so I will take directly tan inverse 0. Is it clear? So this is how we have to simplify. Is it clear, friends? Very, very easy, don't get confused. I'll just remove this so that you don't get confused between this. This is all formulas we have used. Yes. Okay. So next step, you can see tan inverse, this is 0. I will take this 0. This is square root of x square plus a square divided by square root of x square. It is going to become 1. Tan inverse 1 will be pi by 4. Okay. So then this will be equal to, students, you can see very easily, integration 0 to a root 3 x divided by square root of x square plus a square into pi by 4 dx. So pi by 4 is constant, so please bring it outside. This will be equal to pi by 4 integral 0 to a root 3 x divided by x square plus a square dx students. So now we can just simplify. So I'm going to use the formula again. So formula says that integration x divided by square root of x square plus a square is nothing but direct formula. I'm going to use x square plus a square. So this is a standard formula. You have to remember this formula, students. Very important, very easy to remember. Substitute this directly. So therefore integration will give you this is equal to pi by 4 square root of x square plus a square. X is equal to upper limit and lower limit, you substitute. So this is equal to pi by 4. Just substitute a root 3 wherever x is there. Okay, let us substitute. So this will give you root 3 a the whole square plus a square, then minus square root, this is 0 square plus a square. So I've just substituted wherever x is there, upper limit a root 3 and 0. So simplify this ones. This is pi by 4, then yes, this is square root of root 3 square is 3 only, and a square will give you a square, so plus a square minus, here we can see square root and a square is there, so it will get cancelled. So square root and a will get cancelled. Here you can see students 3a square plus a square is there, so this will become 4a square. So this will give you pi by 4 square root of 4a square minus square root of a square. So I can easily remove square root and square will get cancelled. Square root of 4 I will put it as 2, so therefore this is going to give you pi by 4 2a minus a. That's it students, simplify this. So you will get this as 2a minus a is a, so a pi by 4 is the answer students. So please see that you simplify in the same way, practice the example students, you will get the answer very easily. So such type of examples are likely to come in the examination. If you want, I will solve another many problems such way. Yes students, this is the answer we will get. Thank you so much. So notes I will going to put it in the description box. You can go through the visit once again, and some more examples I'm going to simplify. For the next class I'm going to take triple integral. Please stay on the YouTube channel and please subscribe the YouTube channel so that you will get the latest videos. So immediately I'm going to post the triple integration students. Thank you so much. Keep watching the video students. Thank you.